We have a PS.2, PA.1, unknown time frame delta, Bernoulli single server Q, labeled Q. And we're told it's operating in steady state, and it has been determined that the expected steady state customer time through the queue is 2 times the expected queue length, both in steady state. We're asked to determine the time frame delta, the probability mass function for the steady state customer time, and the expected number of people in the queue in steady state. We have these two formulas for the expected number in the queue in steady state, EQ infinity, that is PA times 1 minus PA all over PS minus PA. That's for Bernoulli single server queuing process with arrival probability in a time frame PA and service probability in a time frame PS. Similarly, for the steady state customer time, the time for a new customer to enter and traverse the queue is delta, the time frame, times PS minus PA squared on top, divided by PS minus PA times PS. And from these two equations, and also we were given the ratio of these two, we easily get that 2 is equal to the expected customer time in steady state over the expected queue length in steady state. And that then, by dividing these two formulas, is equal to delta PS minus PA squared over PS PA times 1 minus PA. And simply then plugging in the value of PS is 0.2 and PA is 0.1, doing simple calculations, we get that's delta times 0.19 over 0.018, or delta times 10.5 repeating. And this gives us then a value of delta is equal to 0.189474. That answers the first question, what is the time frame? For the next question, we have by the equation that we just gave for the steady state queue length, that EQ infinity is PA times 1 minus PA all over PS minus PA. Again, PA is 0.1 and PS is 0.2. And so after a very simple calculation, that gives us 0.09 over 0.1 or 0.9, the steady state expected queue length for the Bernoulli single server queuing process. Then we move to the main theorem for steady state customer time of a Bernoulli single server queuing process, which states if Q is PS minus PA over 1 minus PA, then that is 1/9. And if A is 1 minus PA over 1 minus PS, which is 9 over 8, then the steady state customer time at n delta, where delta is the time frame, and n runs as 1, 2, 3, 4, 5, 6, is A times Q, which we just gave, 1 minus Q to the n minus 1, plus 1 minus A PS times 1 minus PS to the n minus 1. When we substitute in these values of Q is 1/9, A is 9 over 8, PA is 0.1, and PS is 0.2, we get this steady state customer time PMF is 0.1 over 0.8 squared, which is 0.64, then times 0.9, 8 over 9 to the n, minus 0.2, 0.8 to the n. And this simplifies to 0.1563, 0.9 times 0.8 repeating to the n over 0.2 times 0.8 to the n, for n equals 1, 2, 3, 4.
Dear U of A students, while Mike has supplied the content for these videos, there is significant unpaid effort that goes into producing these videos. The folks here at Step by Step Probability are family people with young children that no longer attend school due to the COVID shutdown. Instead of spending time with our families, we have made arrangements to continue producing these videos for you. In these uncertain times, it would be very encouraging to see your support through our donation button at the top of the website. Any amount is encouraging and appreciated. Please donate if you can. Thank you, and keep safe.